In this chapter, we're going to look at input and output in Java programs. We're going to look at how to format text and numbers in your output, and then how to get input into our programs from the user so that we're not constantly assigning data directly, so that we can have a little bit of variation in the data that our programs process. So we're going to start with some special characters for formatting output, the new line character and the tab character. If you look at the program in front of you, you'll see that we have our old friend Hello World. And we tell it that in this program, we use the print line method to print the phrase Hello World and then a new line after that so that the cursor moves down to the next line before we output any more text. Another way to do that is to use a special character, the new line character. The new line character can be placed inside a string by typing \n. You have to type the backslash first because the compiler needs to know that what follows, the letter N, is supposed to be interpreted as a new line character and not just as the regular letter N. So when the compiler sees backslash followed by N, it knows that it's supposed to print a new line at that point. Let's compile and run this program. And that's how it works. The new line character can be placed anywhere in a string. I could put it between the word hello and the word world, like so, and then it'll put the new line at that spot. Let's compile again and run. And so you see that it printed hello, comma, then a new line, then a space, then world, then the exclamation point. The only requirement for the special character new line is to put it inside a string. So we could also do something like this. We could have the new line character in a string by itself, \n, close. And then let's compile and run the program. So that it printed the string hello world, then a new line, and then goodbye, and then another new line. So again, the special character new line works anywhere inside a string. You can place it at the beginning of a string, in the middle of a string, or at the end of a string. The only requirements are that it has to be surrounded in quotes. In other words, it has to be inside a string. The other special character I wanted to look at was the tab character, and that's \t. You use tab when you want to put a uniform number of spaces between your text in a program. So for example, we might have a heading that we try to space out using the space bar. The problem with that is we may not type the same number of spaces every time, so that in the end our output looks jagged and not uniform. We can fix that by using the tab character, \t, where the spaces would be, and then the compiler will insert the spaces for us without us having to worry about if we got the right number of spaces or not. So let's compile and then run. And you see that we have a uniform distribution of day 1, day 2, day 3, day 4 across the line using the tab character. The rules for tab are the same as the rules for new line. It just has to be inside a string. It can be its own string, so we could write system out print \t and then system out print line day 5. I had the print line there. Let's get rid of that. Save and run it again. So now we see that day 5 is tabbed over from day 4 and added to our output line. So the two special characters, new line and tab, \n and \t, are useful in formatting your output and can be used inside strings wherever you need them. Java has a special function or method that we can use to set the width and the precision of numbers that we display when we're printing them out, and that's the printf function. So let's take a look at an example. Here we have a final variable pi, and we've set it to 3.14159.263. If we want to display pi to only, let's say, 4 decimal places, we can use the printf function to achieve that. Here's how we do it. Printf will be used with system.out, but instead of print or print line, we're going to use printf. The way it works is we provide a format string that tells the compiler how to format the number. In this case, what we want to do is we're going to tell it that we want to format the number as a floating point number with 4 decimal places after the decimal point. So we start out with the percent sign. That says that we have a formatting string coming, followed by the 0.4 to say 4 decimal places after the decimal point, and then F to signify it's a floating point number. Then we close the string and put a comma, and then we put the variable pi after the comma. That tells the compiler to replace the format string %.4f with the value that's stored in the variable. So let's take a look at how that's going to display. We'll save it, then we compile and run, and so we see it displays 3.1416, so 4 decimal places. We can set this number to whatever we wanted to set it to, 4, 2, 6, 10, and then it would just put zeros after the last 3 of our value of pi. The second thing we can do with the printf function is specify a width or a field width to display the number in. Notice that when we looked at the number previously, let me pull the DOS window back up, the 3 begins 1 space after the equal sign, just like we expected to, looking at the format string, well, the whole string altogether. If we want to put some space between the equal sign and the value, all we have to do is specify a field width. So let's try one. Let's put this to 5 decimal places, and let's say that we want the width to be 10. So we put the 10 before the decimal place, then the 5 saying we want 5 decimal places after the decimal point, and then the F, of course, for floating point. Let's save it. Let's recompile, and then run it again. There's the run right there. Okay, so you see what it did. Field width of 10 means that the whole number, including the decimal places, will fit into that width. Let's change it to something a little more extravagant. Let's try 20, just so you can see how that field width works. So we'll compile, then we'll run. There. And if you count it out from the first space after the equal sign through to the last 9, then you'd see that was fitting into 20. So using the printf function, we can specify a field width and the precision of a number. A lot of times all you'll see is the precision itself, or sometimes all you'll see would be the field width by itself. Let's print that out to see what it does. Notice that the default is 6, which is actually less than the whole number, but that's the default value because we didn't specify. Let's go back and look at the format string. We didn't specify the number of digits, so it defaulted to 6. We could have said 0.1. And again, I'm doing this just to demonstrate the differences in the format strings. And then we could have taken out the field width altogether. Let's change that to 2, just for demonstration purposes. So that's how you use the printf function to specify precision and field widths. To be perfectly honest, printf is a holdover from the C++ language, and I may have mentioned before that Java was designed a lot around C++, but most Java programmers don't use printf unless they're printing out lots of rows and columns of numbers where the specification for a format is very important. Normally, except for maybe the number of decimal places, which there's other ways to control, printf is not used all that much. That finishes the output portion of this chapter. Now we're going to move into input, and we're going to learn how to get input from the user using a special class called the scanner class.